Welcome back, everybody. This is Noah, and in this video we're going to go over the basics of how to use the Geogebra software. So before I even get into writing anything on the page, let's just pull up the software itself. Get the tab going here. Try to fit it into our screen capture window as best I can. There we go. And so I want to go to geogebra.com, geogebra.org, and we can just click Start Calculator. You can also go to the graphing calculator down here. That's what I'm going to click on. It'll take you to the same place. If you're on a computer, you can use your keyboard. You can actually do this on your phone as well, and there will be a keyboard there to help you type things in. This is definitely easier to use on a computer, but the phone version of the app isn't too horrible. What we want to do here is use this to type in a function and then find some key elements of that function once we have it typed in. So I'm going to move this so we will see the function that we're trying to type in. There we go. Okay, so we have a function f of x equals negative 0.01 x squared minus 1.39x plus 30.5. So I'm just going to type in exactly how I see it there. F of x equals negative 0.01 x to the second minus 1.39 x plus 30.5. I used the caret above the 6 on the keyboard in order to get a superscript to put the x squared in there. Go ahead and hit enter. And I don't see anything on the screen here. There's a reason for that. It's because we can't really see it as is. We can zoom out. We can use a scroll wheel on a mouse, or we can use 2 fingers on a touch screen. So here's me using 2 fingers. And as we zoom out more and more, we should be able to get a picture of this. So think of this a lot like a map program that you'll have on your phone. You can use 2 fingers to zoom in and out on that. This will actually have a little bit nicer zooming features than that even, because here we can do a couple different things. If I hold the shift key on a keyboard, we can grab the y-axis and stretch just in that direction, right? So that's just changing our y scale. And similarly, I could grab the x-axis and pull that in and out so I can zoom in that direction in a similar manner. What we want to do here is get this to fit in a nice viewing window where we can see both of the x-intercepts, this one here and this one over here, the y-intercept, and the vertex at the very least. And if we are doing this with a touch screen, then we can use 2 separate fingers. So I've got my left finger on the bottom of the y-axis and my right finger on the top of the y-axis, and I can pull in and out that way to stretch in that direction. So if you're on your phone, this is how you can stretch in just a single direction. And I can grab using 2 separate fingers. You'll probably have to set your phone down. One on each side of the x-axis. I can pull that in and out to get a stretch there. I'm going to go ahead and I really don't need to see all of that down underneath. Stretch this vertically a bit. That seems to be a pretty nice viewing window. So the instructions, let's read those. It says to graph this function using GeoGebra and zoom in and out until you have all the intercepts and the vertex in a nice viewing window. Remember, the vertex to a parabola is that turning point, either the top of the hill or the bottom of the valley if the parabola was upward facing. So I've got all of that information shown here. And now we're going to use GeoGebra to create a table of values. So we can click on these 3 little buttons next to the function on the left side and click on table of values. And we can get this to do this automatically for us. So I could say like start at negative 10 for x and go to, actually let's not do that many. Let's just do negative 3 to, wait, actually, I'm sorry. I want to look at this graph. It looks like we have values from, like the x-intercepts are past negative 150 and then probably around 20 on the right side there. So let's do that for our table of values. Let's say negative 200 to positive, let's go 50, and we'll do steps of, let's do 20. Right, so that's going to, every 20 units, or let's do every 25. Every 25 units is going to give us, it's going to plug in another x value. So it's going to plug in negative 200, then it'll plug in negative 175, then negative 150, and so on and so forth until it gets to 50. If I hit OK, it puts all these points on the graph so we can see them there. And then we have our table of values here on the left. So what I'm going to do is I'm going to take a screenshot of this and insert it into OneNote where we've got this. How do I want to organize this? That's all I'm thinking about right now. Let's put it here for a moment. And let's shrink this down. That pushed. That's way down here. There we go. I'll shrink it down a little bit more. So that's me having created the table of values. And I'm going to go back, and I actually want to show and take a screenshot of what it looked like before that, so we can go back here and click on this. How do I hide the table of values? There we go. Hide those points. Then I'm going to take a screenshot of this. Click on that vertex. And capture this. So on a PC, you can hit the Windows button, Shift, and then S, and that will allow you to take a screenshot, which is really nice. To be able to insert that into your homework every once in a while, or just because you want to insert into a document for whatever it is that you might be looking at a graph for. That, let's put it down at the bottom again. How did that other, oh, took this one down with it. 1 second, let's get this put back where it's supposed to go. There we go. That's better. Right, so we've got these graphs, and we've made our table of values. And so we could see this. Let me go ahead and draw in some of that table here. So for part A, that's all this graph here. And our table of values, that's from the second part. I'm not going to fill in all of this, but we have x and then f of x. So negative 200, negative 150, say, negative 100, negative 50, 0, and 50. That'll be negative 91.5, 14, 69.5 at negative 100. When x is negative 50, we have 75. When x is 0, we have 30.5. When x is 50, we have negative 64. So we're looking now for the x and y intercepts. So the y-intercept we can actually see already. It's this point when x is 0. It's 0, 30.5. And then the x-intercepts are these 2 points where we hit the x-axis. So we've got negative 158.27 approximately, comma 0. And then this point here is 19.27, comma 0. And the y-intercept we said was 0, comma 30.5. So I'll now list the x-intercepts as approximately negative 158.27, comma 0, and the point 19.27, comma 0. The vertex, that's this turning point at the top of the parabola. So that's the point negative 69.5, comma 78.8025. And we want to talk about the domain and the range. It's nice, once we have a graph of this, we can see pretty quickly that the domain is going to be the set of all real numbers, everything from negative infinity to positive infinity. If I look at this graph, this downward facing parabola, I can keep moving to the left for forever, and I can keep moving to the right for forever, and nothing gets skipped. So the domain is everything. The range is all the possible y-value outputs. And we see that this graph does keep going down for forever, but it tops out at the 78.8025 value. So the range is going to be negative infinity up to 78.8025, and we can get to that. That vertex is included. That y value is included in the range. All right, so this is just us going over the basics. You're going to go ahead and do the now you try problem shown in the mind map, and then in the next video I'll go over the answers to those. So go through the same kind of thing. It's going to be a very different kind of window that you have to zoom to. The numbers are very different. In this problem we had these decimal numbers, and the problem you've got these big numbers that are all well over 100, and even the C value, the plus 6,289, is pretty big, so you'll need to zoom out quite a ways on that. But give that a shot, and then in the next video I'll walk through that with you. Thanks much. I'll see you in that next one.